Multiplicity is how many times we see each factor of a polynomial. So if I see a factor twice, it would have a multiplicity of 2. If I see a factor once, it would have a multiplicity of 1. So depending on how many times I see the factor depends on the multiplicity. So here I have x to the 4th minus 6x to the 3rd plus 9x squared. So since it has 3 terms and the exponents are in descending order, I'm going to pull out what all 3 terms have in common. So my first term has a 1 and 4 x's. My second term has a negative 6 and 3 x's. And my last term has a positive 9 and 2 x's. So all 3 terms have 2 x's in common. So I'm going to put an x squared in front, and that leaves me with a 1x squared, subtract 6x, plus 9. Now that inside portion I'm going to factor using either the British method or the box method. So when I factor, I get x subtract 3 and x subtract 3. So I can write that as x subtract 3 squared, and I still have the x squared that all of the terms had in common in front. So I still need to find the roots, so I'm going to set both pieces equal to 0. So I'm going to have x squared equal to 0 and x minus 3 equal to 0. I'm going to only write the x subtract 3 once because it would be the same thing a second time. For the x squared equal to 0, I'm going to take the square root of both sides, and the square root of 0 is 0. So I only saw the x squared term once, but there were 2 x's there. So since there are 2 x's, this makes it have a multiplicity of 2. If it would have just been a single x, then it would have had a multiplicity of 1. If it would have been an x to the 3rd, it would have been a multiplicity of 3. So when you have a single x, its multiplicity is based off of its exponent. For x subtract 3, I'm going to add 3 to both sides, and I'm going to get x equals a positive 3. Now this one, when I factored, I ended up with 2 x subtract 3's, which means I saw the factor twice. So the x equal to 3 will also have a multiplicity of 2.